Good morning, everyone. Today, we are back in our chemistry class. Today, we'll be learning about a new concept, a new topic, mole concept. Our objectives at the end of this lesson, one should be able to define the following: mole, relative atomic mass, molar mass, relative molecular mass, relative formula mass, and molar mass. Also, at the end of this lesson, we should be able to calculate the following: the relative atomic mass, the relative molecular mass, and the relative formula mass. That is the molar mass. And we should be able to convert between mass to mole, mole to mass, number of particles to mole, mole to the number of particles, or we should be able to calculate or convert between mole to mass and mass to number of particles, or vice versa, where we go back from number of particles to mass and mass to mole. All right. So today is going to be an interesting class. Please pay attention, and wherever you fail to understand, please be reminded that this is a video and you can always pause and rewind to make sense of what was explained. So, our first objective: define the following. Mole. What is a mole? A mole is the amount of a substance that contains 6.0 times 10 to the 23 particles of a substance. When we speak about mole, we have to take into consideration the carbon-12 atom. A mole was, originally a mole was compared to 12 grams of the carbon-12. And so the definition, we could say a mole is the amount of substance that contains the same number of particles, 6.0 times 10 to the 23 atoms, as there are atoms in 12 grams of the carbon-12, right? So it was found that 12 grams of carbon-12 contains 6.0 times 10 to the 23 atoms. And therefore, a mole represents 6.0 times 10 to the 23. So again, what is a mole? The short of it is that a mole is the amount of substance that contains 6.0 times 10 to the 23 particles of the substance. Next, we have relative atomic mass. Relative atomic mass is the average mass of one atom of an element. Let me say that again. Relative atomic mass, which is represented by the symbol AR, is the average mass of one atom of an element compared to 1/12 the mass of an atom of carbon-12. The word average is used in the definition because relative atomic mass takes into consideration the relative abundance of each isotope. Relative atomic mass has no unit because it is a comparative value. All right, if you look at it, it's comparing one element to that of the carbon-12. All right. Now, the next term in question is relative molecular mass. Relative molecular mass, which would be represented by MR, is the average mass of one molecule of an element or compound compared to 1/12 the mass of an atom of carbon-12. Relative formula mass. So what is relative formula mass? Relative formula mass is used when describing ionic compounds. All right, so we see earlier that relative molecular mass is used when describing covalent compounds or compounds that are consisting of covalent bonding, while relative formula mass is used when referring to ionic compounds. Relative formula mass is the average mass of one formula unit of an ionic compound compared to 1/12 of the mass of an atom of the carbon 12. All right, how do we calculate these? All right, so I'm going to dive into some example of calculations for the different things that we have just looked at: relative atomic mass, relative molecular mass, and formula mass. But before we do that, let us look at molar mass and to define what is molar mass. Right? So molar mass, which is represented by M, capital M. Molar mass is the mass in gram of 1 mole of a chemical substance. And I repeat, molar mass is the mass in gram of 1 mole of a chemical substance. So we see then that relative atomic mass, relative molecular mass, and relative formula mass, they are all examples of molar mass. Okay? So when we calculate the relative atomic mass of an element, then we are finding the molar mass of that element. When we calculate the relative molecular mass of a covalent compound, what we are finding is the molar mass of that covalent compound. And when we calculate the relative formula mass of an ionic compound, what we are calculating is the molar mass of that ionic compound. Okay? All right, so our next objective is to calculate the following. Relative atomic mass. That's the first one we're going to look at. Relative atomic mass. Now, earlier I said when we speak of relative atomic mass, then we're talking about the molar mass of an element. All right, my favorite example is sodium. Sodium is a metal that is found in group 1 and it has an atomic mass of 11. So it has an atomic mass. It has an atomic number, my apology. It has an atomic number of 11. Now, sodium has a symbol Na, and the nuclear notation for sodium would be Na with 23 at the top, which represents the mass number. The mass number is a sum of the number of proton plus the number of neutron within the nucleus of the atom, of the sodium atom. So we see that there are 11 proton plus 12 neutron. So at the end of it, the atomic mass is 23 grams. So the mass number of sodium is 23 grams. And again, I said it is the number of proton plus neutron within the nucleus of the sodium atom. At the bottom, we have 11. This represents the atomic number. And the atomic number is simply the number of proton within the atom of the element. All right? So I'm going to have here proton number. Now, how do we then calculate the relative atomic mass of sodium? Well, the truth is the relative atomic mass is simply the mass of one of that atom, which is 23 grams. So the relative RAM, relative atomic mass of sodium is simply the mass atom, which is 23 grams. So we see then it is 23 grams per mole. 23 grams per mole can also be written as 23 grams. And instead of writing the slash, you could write mole -1. So that's another way to write 23 grams per mole. Both of them are saying the same thing. Okay? Therefore, as it relates to atomic mass, it is always advised that one knows the first 20 elements of the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphor, sulfur, chlorine, argon, potassium, and calcium. It is important to know the first 20 elements by heart and to know their atomic number and their mass number. All right? So again, another example that we could use is magnesium, Mg. Mg, the nuclear notation for magnesium is Mg, 24 at the top representing the mass number, and 12 at the bottom representing the atomic number. Okay? Again, the relative atomic mass would be equal to the mass number, the mass of one of that atom of magnesium. So it would be 24 grams per mole. And as I said, I like to write it both ways for persons to understand that they can write it both ways. All right? So whichever way you choose to write it, it is correct. All right? Now we're going to look at how to calculate relative molecular masses. Relative molecular masses, right? Also, again, relative molecular mass is simply the molar mass of the covalent compound. Now, two examples I'm going to use today. I'm going to use an example. This is familiar to all, H2O. And I'm going to use an alkane. The alkane that I'm going to use is ethane, C2H6. Right? So I'm going to use ethane to calculate the relative molecular masses of these two covalent compounds. All right, so covalent compounds are comprised of atoms that are bonded covalently together. All right? It is compounds that are made from covalent bond where electrons are shared rather than electrons are loose and gain or lost and gain. Electrons are shared, all right, between the atoms that are involved. Water. How do we then calculate the relative molecular mass of water? We must remember the relative atomic mass of each element that are involved. We see here that water consists of hydrogen, which has a relative atomic mass of 1. And it also consists of the element oxygen, which has a relative atomic mass of 16. All right? So, next thing that we need to take into consideration is the amount of atom that is within the formula of the compound. And we see that there are 2 hydrogens, so we multiply the mass of hydrogen by 2. When we look at oxygen in the formula, we see that there is only 1 oxygen, and therefore we do not have to multiply. It is already 16 grams. So at the end of the day, the relative molecular mass of water is now 2 times 1 gram, which is equal to 2 grams plus 16 grams, which is equal to 18 grams per mole. Because remember, when we talk about relative molecular mass, we're talking about the molar mass. And the molar mass says that it is the mass of 1 mole of the substance. So 1 mole of water has a mass of 18 grams. And therefore, we must express it like this: 18 grams per mole. Now, let us look at the other example on the board. The other example would be ethane, which is C2H6. Again, guys, I will repeat, I will make this known, I will make it clear. We must know the atomic number and the mass number of at least the first 20 elements of the periodic table. Go and study those elements and know their masses and atomic number. I repeat. Okay, so we see that when we look at the formula of ethane, there are 2 carbons and there are hydrogens within the formula. So first, we must write the mass number of carbon, which is 12 grams. And then we identify the other element, which is hydrogen, and the mass of hydrogen again is 1 gram. When we look at the formula, we see that there are 2 carbons, so we multiply by 2. When we look again, we see that hydrogen, there are 6, so we multiply by 6. 2 times 12 is 24 grams, plus 6 times 1 is 6 grams. All right, and we see then that the relative molecular mass is equal to 24 plus 6, which is equal to 30 grams per mole. All right, again I repeat, the molar mass, if any substance is 1 mole, is the mass of 1 mole of that substance. Okay, now when we look at relative formula mass, again we're looking at the molar mass of these ionic compounds. There are 2 compounds in the board, sodium chloride and magnesium sulfate. So we're going to calculate the relative formula mass of these 2 compounds. Again, know the mass of each atom or each element that is here. So we identify from sodium chloride that sodium is present, and sodium has a mass of 23 grams, and chlorine has a mass of 35 grams. How many chlorine are there? 1. So we do not need to multiply. How much chlorine are there? 1. No need for multiply. So we can simply go ahead and add 23 plus 35, which is equal to 58 grams per mole. So we see that the relative formula mass of sodium chloride is 58 grams per mole. Okay, while magnesium, the mass of magnesium is 24 grams, and the mass of sulfur is equal to okay, so the space was limited on that side of the board, so I'm going to rewrite this one. So the mass of magnesium is equal to 24 grams. The mass of sulfur is 32 grams, and the mass of oxygen is equal to 16 grams. Now when we look at the formula of magnesium sulfate, you see that there is 1 magnesium, so 24 grams is okay. 1 sulfur, 32 grams is okay. However, oxygen, we see that there are 4 oxygen present, so we multiply by 4. So now we have 24 plus 32 plus 4 times 16. 4 6 is 24. 4 ones, 4 plus 2, 6, so that is 64 gram, all right? And in total, we have 64 plus 32, which is equal to 98. 98 and 20 is equal to 118, and 4, 122. So that's 122 gram per mole. So we see then that magnesium sulfate has a relative formula mass of 122 grams per mole. All right. Now let us look at some conversions. All right. So today we are going to convert from mole. So when we talk about mole concept, then the truth is we must do some conversions. So we are going to convert from mass to mole, and from mole to mass. All right, so that's the first that we're going to look at. First set of conversions that we're going to look at for our objective that we decide that we're going to cover today. All right, so molar mass is the mass in gram of 1 mole of a chemical substance. All right, and we can use the molar mass to help in our conversion. All right, so the first is molar mass, mass to mole. That's the first thing that we're going to look at. And to convert, to find the mole is equal to given mass divided by molar mass. All right, so to find the number of mole, that would be given mass divided by molar mass, or mass of 1 mole of the substance. All right, and we know that 1 mole is equal to either the relative atomic mass, relative formula mass, or relative molecular mass of whatever substance that we're looking at. All right, so the example that we'll be using here today is mass of water, of 27 grams of water. We're going to convert this given mass of water into the amount of mole that is present. The first thing that I recommend is to find the RMM of water. RMM of water. That's the first thing that I would recommend. RMM of H2O. And we did that earlier, and we said that the RMM was hydrogen, mass of hydrogen, times 2 plus the mass of oxygen, which equals to 18 grams per mole. So we see then that the relative molecular mass of water is 18 grams per mole. All right, and here in the example, we are asked to find the number of mole that is in 27 grams. All right, so the number of mole that is in 27 grams would equal to 1 mole of H2O equal 18 grams. Therefore, X mole of water is equal to 27 grams. We cross multiply X times 18 and 27 times 1 mole, which is equal to 1 times 27 gram, which is equal to 1 mole times 27 grams, and X times 18 gram. All right, so to make X the subject of the formula, it's going to be 1 mole times 27 gram divided by 18 gram. do the calculation, gram per gram, and we can then go and multiply and to do the operation. And we will see that X is equal to 1.5 mole. So 1.5 mole is present in 27 grams of water. All right, so 1.5 mole is present in 27 grams of water. So on the board we have iron 3 sulfate, my apology. So we have iron 3 sulfate, and we're going to use that to calculate from mole to mass. So we're going to find the mass of 0.25 mole of iron 3 sulfate. So the first thing that we need to do is to calculate the molar mass of Fe2SO4 3. We see that there are 2 ions present, so it's 2 times 56. All right, 2 ions, so it's 2 times 56. 2 times 56, 56 is the mass of iron. And then we see that there is sulfur in the formula, and in the bracket, outside the bracket, we have 3. Therefore, there are 3 sulfur. And so we have to multiply the mass of sulfur, 32 times 3. Also, oxygen, when we look, we see that there are 4 oxygen here, but outside the bracket, we have 3. So we have to multiply by 3 by 4 the mass number of oxygen in order to get the total mass of oxygen present. When we add everything, we see that the mass is 400 grams. Okay, so the mass of 0.25 mole of Fe2SO4 bracket 3 is equal to 0.25 times the 400, the molar mass, which is 400, which will give us a mass of 100 grams. Okay, so on the board we are going to look at how to calculate mole to number of particles. All right, so what we have on the board, we have the formula. In order to calculate the mole, the number of mole, then we will have to look at the given number of particles and to divide it by the number of particles that are present within 1 mole of that substance. The example on the board is nitrogen molecules. Number of moles in 1.8 times 10 to the 23 nitrogen molecule. Now, if 1 mole, as I said earlier, has or contains 6.0 times 10 to the 23 particles, then what we'll have to do is to divide the given number of particles, which is 1.8 times 10 to the 23, by the number of particles that is in 1 mole, 6.0 times 10 to the 23. When we do the operation, we get 0.3. So 1.8 times 10 to the 23 divided by 6.0 times 10 to the 23 is equal to 0.3 moles, as is shown. All right, so we can also calculate the number of particles from a given number of mole. And the formula would be number of particles equal to given number of mole times 6.0 times 10 to the 23. All right, so if we want to calculate the number of magnesium oxide formula unit in 0.75 mole, then we would simply say that 0.75 mole of magnesium oxide contains 0.75 times 6.0 times 10 to the 23, which gives us 4.5 times 10 to the 23 magnesium oxide formula unit. All right. Okay. Also, we can look at the number of particles that is within a given mole of a of a substance. So here we are asked, the example on the board asks, how many chloride ions are there in 0.2 mole of aluminum chloride? Aluminum chloride, AlCl3. We know that 1 mole of AlCl3 is equal to 6.0 times 10 to the 23 molar formula units. Formula units here represent the particles, of ionic compounds. Therefore, 0.2 mole of aluminum chloride contains 0.2 times 6.0 times 10 to the 23. When you do the operation, you'll get 1.2 times 10 to the 23 formula unit. Now, within one aluminum chloride formula unit, there is 3, as you can see, there are 3 chloride ions. How many chloride ions are there? 3 chloride ions. So there are 3 chloride ions. Now, 1.2 times 10 to the 23 aluminum chloride formula unit was calculated to be in 0.2 moles of aluminum chloride. Therefore, within that 1.2 times 10 to the 23 aluminum chloride formula unit, we want to know how much or how many chloride ions are there. And since there are 3 times chloride ion, then we times that 1.2 times 10 to the 23, which we have calculated here, by 3. 3 times 1.2 times 10 to the 23 is equal to 3.6 times 10 to the 23 chloride ion. Okay, so we can calculate, now that we know how to calculate from mole to number of particles and from mole to mass and vice versa, we can also calculate from mass directly to number of moles. On the board we have how many ammonium molecules are in 4.25 grams of ammonia. The molar mass of ammonia is 14 plus 3 times 1, which is equal to 17 grams per mole. The number of moles in 4.25 gram would be 4.25 divided by 17 grams, which is equal to 0.25 moles. So we see then that 0.25 moles, that's the amount of mole that is within 4.25 grams of ammonia. We also know that 1 mole of ammonia contains 6.0 times 10 to the 23 NH3 molecules, right, or number of particles. Therefore, 0.25 mole of NH3 contains 0.25 times 6.0 times 10 to the 23, and that would gives us the number of particles that are present, which is 1.5 times 10 to the 23 ammonia molecules. All right, calculate the mass of 2.4 times 10 to the 22 calcium nitrate formula unit. 1 mole of calcium nitrate contains 6.0 times 10 to the 23. As it's 1 mole of any substance contains 6.0 times 10 to the 23. The number of moles in 2.4 times 10 to the 22, as the question asks us to calculate, is therefore then equal to 2.4 times 10 to the 22 divided by 6.0 times 10 to the 23. And when you do the operation using your calculator, you'll get 0.04 moles. All right. So therefore, 0.04 moles of calcium nitrate is present in 2.4 times 10 to the 22 formula units of calcium nitrate. All right. So therefore, we can now calculate the mass using the mole that we had just calculated. So the mass therefore is equal to the mass of the number of mole calculated times the molar mass of calcium nitrate, which is 164. So it's 0.04 times 164, which is equal to 6.56 grams. So the number of moles is the gram, or the mass calculated, is 6.56 gram. So there we go. That's the end of it. We have covered all objectives. This video is a bit long, and I'm sorry for that.